So, my name is Paul Riegel. I'm the Chief Product Officer here at Algorand. I get the distinct opportunity today to talk to you all about our core technology strategy and a little bit about our protocol roadmap. You guys ready? Everybody ready? All right, cool. I'm going to start with a little bit of a left turn here. I'm going to start with a quote that I really like, I've liked throughout my career, and I've been thinking about a lot lately. And that quote is, "Any sufficiently advanced technology is indistinguishable from magic." This is a quote from a gentleman named Arthur C. Clarke. If you're familiar with him, he was a science fiction writer. He's a futurist. If you're into that genre, he's maybe best known for co-writing 2001: A Space Odyssey. But the quote, so any sufficiently advanced technology is indistinguishable from magic. Why do I like this quote? First of all, because I like magic. It's fun. But second of all, I've been thinking about it a lot lately because blockchain technology, I think a lot of people in this room would agree, in certain areas, is sufficiently advanced that one can maybe think of it as magic occasionally. And I think this is an important thing. I think it's fun as a technologist. I think that you need to be able to take joy in the technology that you represent. You need to be able to leave behind the constraints of the practical world. You need to be able to leave behind critical thinking, leave behind established science, and really just believe in what the technology could be. And it's important to do that. It's important to be excited about the technology. But like anything, too much of a good thing turns into a bad thing. And I think what we've seen in our industry is we've seen a lot of people decide that they're just going to buy into magic generally. I don't want to actually have to learn the underlying technology. I don't want to have to actually figure out what the nuances are between these blockchains. I'm just going to go with magic because it's fun. The problem with that is when you start trying to compare underlying technologies or compare magic, it's really hard to compare magic. And so what you do is you start chasing magicians. So this is Chris Angel. The internet has assured me this is a very famous magician around the world. And I'll tell you what, I can understand why people like to chase magicians, because searching for pictures of magicians lead me to things like this. And this is a live show. I mean, it seems like a little cooler than my show. I want to go to this show. I get why magic is exciting, okay? And it's particularly more exciting than this, right? What is this? This is like decision flows, and it's Excel sheets, and it's primary research, and it's like, well, I've got a technology stack for a product that I'm building, and I'm looking for a new technology to bring into that stack. How do I think about actually which technology to use? And once I decide on which technology to use, how do I actually get that into my stack? All that's hard. All this is easy. I like it. However, the problem is if you start chasing magicians, without fail, every one of these magicians, they're going to let you down. And they're going to let you down because they're not actually practicing magic. They're practicing sleight of hand. They're practicing smoke and mirrors. So what do you do then? I've just stood up here and told you, hey, you can't think about magic. Well, you should think about magic a little bit, but not a lot, or you're going to get yourself in trouble. So how do you think about technology, and how do you really get into what it is, the differences between these technologies? How do you apply them? There's a couple of things you need to be looking for. Number one, you need to be looking for a clear vision. Should it be exciting? Yeah, it should be exciting too. But it should be clear. You should be able to understand it. It should stand up to questioning. You should be able to explain it to other people that you know. Two, the science needs to be sound. This is a sufficiently advanced technology, as we were saying before. It needs the science behind it. A white paper is not science. Science is science, okay? And thirdly, you need to be looking for projects and teams that execute. They execute consistently. They continue to shape the technology. This is not an environment where you just decide, hey, I built a blockchain, kick it out the door, and go figure it out. This is a thing where you have to bring it every single day. You have to execute. You have to shape it. You have to make it better, and you have to keep it at the forefront of technology. And I'm going to get a little bit fired up today, so hopefully that plays well with you guys, but that's just what's going to have to happen. So when we talk about execution, I want to talk about what we are executing on every day and what our team goes to battle with every single day to improve. And it's these three things up here. This is our strategic priorities. Core protocol properties, programmability, interoperability. If you were at the Cypher last year, you would have seen the exact same three strategic priorities. Why is that? Because these are the brass tacks. This is what it takes to succeed. If one of you comes up to me after this and says, hey, look, I'm thinking about starting a blockchain, what do I need to be thinking about? I'm going to talk to you about these three things. Every single day, making them better. They don't get done. You continue to improve them. So I'm going to talk about each one of these in specific. Core protocol properties. I believe that blockchain protocols will embed themselves in our way of life just like other protocols have embedded themselves before. HTTP, for example. And when you get embedded, you get access to a huge amount of users. Because you're not really talking about HTTP anymore, you're talking about the value-added products and services that are built on top of that. But in order to get selected to actually get that access, your protocol has to have sufficient properties to earn that. And it's things like capacity, it's things like latency, it's things like finality, decentralization, reliability, it's a lot of things. And that's what we are focused on every single day building this protocol. Specifically in 2022, we've been really focused on two things, capacity and latency. We have improved the protocol from roughly 1,000 transactions a second up to 6,000 transactions a second, huge improvement. We've, at the same time, dropped the latency of those blocks, the block latency, from about 4.5 seconds down to 3.7 seconds. And our focus going forward is to continue to drop that round time. Our goal is going to be somewhere in the 2-second range. Why is that important? Now, obviously, that's going to lift up TPS. If you're doing the same amount of transactions in a shorter amount of time, you're doing more transactions in that unit of time. But more importantly, we're focused on this because of the user experience that it brings. The difference between Web 2 and Web 3 applications is a lot sort of philosophically and under the hood. But the tangible difference is the user experience that some blockchains enforce and impart upon the applications that you're building. Your user experience can be limited by the blockchain you choose underneath it. And the easiest thing to talk about here is sort of what I call transaction finality. So if you're on a user's on an application, they click a button. How long does it take from the time that I click that button to the time that thing is actually done, right? And I know you're probably told there's no math. There is some math, but fortunately it's very simple math. This equation is really easy to think about. There's two pieces that you're going to add together. The first thing is your block latency. When you press that button, a transaction is going to be sent out into the network. It's got to get into a block. It's got to get washed through the system. The second piece is the block finality. Okay, you've got a block. How long does it take for that block to be final? Right? It's two pieces. You add them together. That's what that user is going to experience when they click a button. So I'll give you an example of a hypothetical blockchain that is not Algorand. Let's say it's got 500 millisecond blocks. Bang, 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 block, block, block. Feels pretty good. Feels like a Web 2 experience, except for there's two pieces to that equation. Second piece is the finality. Let's say that finality is 10 to 12 seconds. So I press that button. Hold on a second. Okay, and now we're done. That user experience is an unacceptable user experience for a Web 2 user. And make no mistake, we are after the Web 2 users. That's where this is going. So you have to really be focused on that user experience. Now at Algorand, that was a hypothetical blockchain. We're a little bit different. We have the same equation, block latency, block finality. Our block finality time is always 0. As soon as the transaction gets into blocks, it is final. So lucky for us, we just get a focus on block latency. And that's why we're continuing to squeeze that down. Sure, higher TPS. More importantly, it allows you builders to build applications on Algorand that simply are not possible on other blockchains because you're limited by the underlying technology. Second thing on this page, reliability and robustness. You might say, hey, Paul, I don't think you guys have a problem there. I think I saw a slide Stacy put up there, zero downtime. One of the things I like about Algorand is technology that just works. And I would tell you, I agree with that. But I'm also here to tell you that 0 seconds downtime, that technology that just works, it's not easy and it's not cheap. It takes continual investment and continual work to get us there. And we're going to double down to make sure that you guys have a protocol that can support you not just now, but meet the needs and meet your bar for reliability in the future. There's a huge emphasis, always a huge emphasis, and I want to make sure that we say that because it's not free. We work really hard for that, and we're excited to work hard for that for you guys. Okay, let's talk about programmability. So if core protocol properties is the table stakes, programmability is the game that stake gets you into. I cannot overstate how important programmability is to not just our blockchain, but blockchain in general. The trust minimized applications that the world is begging for right now can only be built on blockchains and can only be built backed by smart contracts. Okay? And by the way, they will only be built on platforms that have world-class smart contract platforms. And for the last year, we have been laser focused on bringing the AVM and our smart contract platform right to the front of the pack to make it the best possible smart contract platform we can. We have increased compute budget for smart contracts by 256x. That's a crazy number. We have introduced contract-to-contract composability. We've introduced unlimited global storage for our smart contracts. That's in beta net right now. And we've introduced a litany of improvements across the AVM, across tooling, across our languages, to make sure we've got the best possible platform out there. And our continued focus now is about the developer experience of building smart contracts, deploying smart contracts, maintaining smart contracts. And it results in features like simulation, which reduces the constraints when you're building those smart contracts. Better data access to make your smart contracts easier to write. A reimagined indexer to make sure your dApps have exactly and only the data that you want to run your app, regardless of how much processing you need to do with that data before it gets to you. And then, of course, we need a cohesive and full set of tools to make sure people can get into this ecosystem and understand and use this smart contract platform, this world-class smart contract platform. And John Woods from the foundation, he's coming up after me. He's going to talk about ALGO Kit. It's one of those projects that's going to make a huge dent in the way people interact with this programmability layer on Algorand. And finally, I'm going to talk about interoperability. So I'm not going to talk a lot about this now. I've talked a lot about this in the recent past, in the last couple months, and a lot of people have. Interoperability is about reducing the risk of cross-chain bridging and cross-chain composability. It is our responsibility, our meaning layer 1 protocol and all layer 1 protocols, to help reduce that risk. And we've done that with a piece of technology we call state proofs. Now, there's only one 2022 accomplishment on this slide, but this is the culmination of just a ton of work, from our theoretical researchers to our cryptography researchers to our engineers to our product managers. Putting out post-quantum safe state proofs is a game-changing piece of technology in this area, and we're super excited about it. We're super excited about it, though, not just because it's fun to push out technology, which of course it is. We are excited about it because of the reaction that we've got from you and from builders throughout the ecosystem who have said, I want to include this in my application. I want to improve the trust that's required to use my application. Very excited about it. And in order to make sure we get the widest possible usage, we're focused on making sure that there are many flavors of state proofs that meet many flavors of use cases. So for example, we have a post-quantum state proof that's out now. We're going to have a snark version of that for resource-limited environments. There are use cases that are willing to give up a little bit of the post-quantum security for lower latency in generation times. We're going to meet those needs. We've talked to people who are saying, hey, listen, I love these state proofs. I want to be able to commit to a broader set of state than we are right now, typically around composability use cases. Great, we're going to meet that too. State proofs are a game changer and changing the way that people are bridging and using composability, and we are going to make sure that this technology gets out there and is used in as many possible use cases as we can. And so I'm going to wrap up on this. These are the three strategic pillars right here: core protocol properties, programmability, interoperability. I hope what I'm leaving you with is, one, we have a very clear vision of what we're doing here. It makes sense, it holds up to questioning, and you can explain it to your friends when they ask you. Two, we are backed by sound science. We 100% believe in that, and our research team drives the really hard technology that we put out there. And that's important because it's really, really complex technology. And then thirdly, I hope you take away that we are executing, and we will continue to execute. And it is our mission to make sure that this protocol continues to stay on the front edge of blockchain protocols and continues to deliver you all the experience that you need to be successful in this arena. And with that, I just want to say thank you for giving me the time up here to talk about this roadmap. I'm going to bring out John Woods. He's going to talk to you about ALGO Kit, which is one of the tools for the programmability layer. Very excited to see what he's got to say about that. Thank you.